Welcome to today's session where we will look at how to prepare for our interviews. Basically, it's going to be an interactive session where you'll have to talk to me, right? I'm going to ask questions, you're going to answer, and then we will see what is the best answer or how we can get there, right? That's this session is all about, where we look at different scenarios, different aspects of what kind of job questions usually are asked. These are kind of questions which are shared by our students. We've kind of collated all of them and we are here. Confirming, I'm hoping you guys can see my screen okay. Shahid, can you confirm me that, dear? I'll skip through this. You guys know how to reach us by now. For those who are new, this is how you can reach us. Best is to get connected on that WhatsApp group what we have, or send email to support, and it opens up a ticket for you and we kind of get back to you for resolving that. We've been having a lot of success stories too to share with you. These are the participants, what you see, a few of them on the screen with their LinkedIn profiles, who have successfully written the exam and cleared it as well with convenient and ease. We know now, we have gone through those sessions, we know what needs to be done. And you focus on what the syllabus is, and if you focus on listening into all the videos, and I'm hoping you have attended all the classes what we've done and done the hands-on. These exams are hands-on. I'm sure you know all of it. I'm just now recapping it. CV building is an important aspect as well for interviewing in the job, right? So the thing is, before you meet them in person, your CV meets them first. So it's very important to make that first impression, and having the CV written in a nice way is very, very important. And there is no straight way that this is the way you need to write it. Everybody has a unique style, and if you go to just Word, and it has quite a few templates of preparing your CV as well. We will look at it, and what we have is we help you, or we have a couple of sample CVs out there on the portal, which has a template of what job descriptions typically a Kubernetes administrator is expected to do, and how would you, after getting certified yourself and after acquiring the knowledge what is needed, how would you word your CVs? You can look at that, and from there you can build on top of it. And most important thing is, if you are certified on certifications like CKA, CKS, and CKAD, things around that are little compared to other professional certifications what we have. It's a bit of challenging because these are all performance-oriented exams where you're expected to go do those things, and if you get these certifications, it's definitely going to add value. Right? This is the common template what we make use of. Right? So if you're given if you are recruiting somebody, and if you have given an opportunity to hire, and if you have resume on the left or on the right, right? So if you are a recruiter, I'm sure if I ask you this question, which one will you choose? If you are a recruiter, what would your answer be? Will that be the resume on the left hand side or the resume on the right hand side? You put it in the chat if you don't want to talk to me. Either L or R, that should be okay.
R.
Right. And the reason for that is, you have your credentials right up there. And if I am a recruiter, I do not have maybe time to read all of your summary. That's my job. I know, I understand. I should read all of that. But at the first glance, when I have a lot of CVs, I would look for something, which stands out. Now, when they know I've done a CKA, they know I know about it. Right? And getting these certifications is not easy. It's not like you've study a bunch of syllabus and go do those MCQs. So that's the reason we kind of emphasize on you getting certified before you start applying to it. Just warming up, don't worry, we'll go look at the technical stuff, but that's the impact it's going to do. So what we request you is go through those activity guides what we have, practice them thoroughly in your free time. Please take some time out, write those exams, and it's going to be a game changer for you once you have that badges on your CV, on your LinkedIn. That's definitely going to really add value around that. All right. And in your portal, if you go back and you can find these sample CVs on the K21 portal, which will help you to prepare your own resumes. Right. under your sections of lesson topics, if you scroll down to the end of it, you have some sample questions out there, and then based on what kind of experience you have. Thumb rule is never write anything which you don't know. And of course, we should not be lying things on the resume because it's our template. And of course, we come from a lot of other experience as well. We can put all of them, but typically, what is expected out of from a job description point of view, from the administrator or CK80 or CKS, the security oriented stuff, looking at those job descriptions, when you are certified, of course, you know all of them. So how would you word your CVs is what you'll find it here. There are some samples for the people who are relatively fresher. There's some samples for people who are relatively experienced. So you can look at that. Of course, everybody is unique. You have your own set of value you bring to the table, and then you can look at these CVs and you can build around it. But not to worry, if you need help as well, you can reach out to support, and they will go through that and then help you build those resumes as well. This is where you will find it under your portal. And for CKA, CK80, you also will find your interview questions as well. The same questions what we are going to discuss right now, similar ones. All right, so how would a typical job description look like? This is where we have got it from the various job sites what we have. I'm going to show you that as well when we move past all of these slides, and we go search on them based on which geographic location you belong to, and whichever the popular job search engine is there. Search for job descriptions around the DevOps engineers or the engineers CKA, CK80s and stuff around that. Typically, this is what you would find. The Kubernetes engineer to design and build and implement those architectures around that, and how do you configure, set up those clusters, how do you maintain them, when you have to add multiple users, what will you do, things around that is what is expected out of an admin per se. When you are a developer, you're expected to deploy these applications out there. How do you integrate that with existing pipelines if they're making use of CI/CD? Or how do you write those manifests in a better way and secure way, make use of different facets what we've learned, like security context, and build your network policies. Things around that is what you will find. And most of the requirements, if you look at it, in the requirements, they talk more about, better to be certified. One good thing is there's not many of us who are certified, right? Like I said, it's not flooded. It's not like the old Java, or we have hundreds of people who've been using it from last 20-25 years. It's not that. It's relatively new. It came out in 2014, and then things are catching up right now. So you definitely have an edge, and the competition is lesser. But this is how a typical job description would look like. Some more where they talk about, there's another job description from another job, what we've picked up, right? And this is how the little bit of overall summary. This is what we're trying to focus. Let's go and look at few questions. We have kind of categorized them, and like as a basic question, the typical questions, and then we deep dive a little bit. Now the thing is, unfortunately, I do not know the answers for any one of these questions as well. So what's going to happen is I'm going to show you the question, and you will have to answer those questions for me, right? And then we'll maybe debate. Maybe it is correct, maybe it is wrong. I don't know, right? So let's get started. I want this session to be interactive. Usually, what we do when I'm teaching, I ask you not to kind of interrupt the flow. We kind of ask those questions on the chat, and then we give time to talk. We're going to reverse that. I'm going to keep my mouth shut. You have to tell me what I need to do. All right. Okay. So what's one of the basic questions? What is an orchestration, or what is an orchestration tool when it comes to software and DevOps? In our sense, if we come back and look at just the, from the Kubernetes point of view, or maybe in the application orchestrator point of view, these orchestrators are the systems which help you deploy and manage your applications, right? It can deploy your application workloads, dynamically respond to changes. Maybe, for example, if you want, if that's the Kubernetes interview, you can bring in the features of Kubernetes there, and you can say, hey, it can help you deploy your application, scale it up and down dynamically, according to demand, self-heal when things break, perform zero downtime rollouts for you, things around that. Now, what processes? Control plane, we call it as control plane, right? Master node, control plane, manager node, all of it. What makes it as a manager? What components make it as a manager? In the Kubernetes though, there are a few components which make a node as master or control plane as we call it as. What are those 4 or 5 components? Kube controller manager, awesome, correct. 4 components, right? Now tell me this, why do we need them? What is the role they play? 4 components, the answer is correct. You have scheduler. First you have the API server, you have the HCD, you have the scheduler, then you have kube controller manager. Okay, good. So what do they do? API server, the primary communication point, right? Anybody who wants to get any work done with your Kubernetes cluster, they talk to it, the API server. Communication gateway, both internal components and the external people like us who want to post anything to our Kubernetes cluster are going to talk to API server. Long story short, what does this guy do? 3 things: authentication, authorization, request validation, admission control. What are those? We have done this all in deep dive. I'm going to summarize it. I want you to take note. If you're taking note, go back and refer those in depth. What is authentication? It checks who you are. You're trying to post something. I'm telling create a deployment. It's going to stop you. Like the security guard who stops me outside the office and I'm trying to enter my office is going to show me. Now to show him my ID card before I get inside. Right? That's the authentication. Authorization. Okay, you're valid. What can you do? What powers do you have? Is what the authorization. That's where the role-based access control kicks in. It checks what you're trying to create is a valid request or not. And it also does admission control. Even though you authenticated authorized users, we can implement some policies, which usually we do in CKS. We don't do it in CKA. I showed you as an example of pod security policy when we looked at CKA concepts, where it can either allow you or deny you. Those kind of admission controllers are called as validating admission controllers. It can modify the behavior. Those are called as the mutating. Again, if you're not confident around these topics, don't bring it up. The usual tendency of the people who interview is they want you to fumble and they want you to make some mistakes the way they can score some brownie points. Basically, they try to put you in the panic situation where they can try to extract. So if you are kind of comfortable around these topics, talk about it. Otherwise, don't deep dive. Usually, typically, when they ask you this question, when you give that answer, follow-up questions are those. What do they do? What do those components do? Right? So you've got to look at around that. And these are again generic questions. Adding on to the other question is what components are the worker node components per se? Kubelet, a container runtime, and a kube proxy. What are those 3 components if we quickly discuss? Kubelet is your main Kubernetes agent, which runs on every node of your cluster, which primarily watches your API server for new tasks, takes that, gets it done from your container runtime. Now there can be questions around that runtime as well. Now they can bring in the topic of Docker shim being deprecated in the new versions. 1.24 they deprecated, right? So we have discussed around why and what and how when it gets deprecated, what happens. And container D is what we make use of right now. So when it opens up from one question leads to another question, so you need to think around that as well. So container runtime, you don't talk about, they ask you for some examples on container runtime. Talk about container D cryo. Don't talk about Docker, then they will ask you questions around, oh, we've heard somewhere the Docker is deprecated, what can we do? Then it opens up, takes the conversation somewhere else. But having said that, you should be aware of what got deprecated. We have spoken about it in length, so you should be able to convincingly answer that questions as well. Make note, you need to know about it, because that's one of the common questions what's coming across nowadays. 1.24 was in April this year, and that's one good question. Maybe the interviewer does not know what's going on. He wants to know it from you as well. That can also be a possibility. Typical question is what are features of Kubernetes? What can it give you? Right. So to name a few basic features, it provides you self-healing. Then the question comes around what is self-healing? Things break, it automatically fixes. Then they say, can you give me an example? Give an example of the Replica set controller which can self-heal for you. Right? Pod dies, you tell what replica is it. And how do these controllers do is they run the infinite watch loop, which we call it as diagnostic loop controllers, which keep an eye. What do they keep an eye on? Your desired state, your current state, and it observes that, and it tries to find out if there are any differences, reconcile that, and that's how it kind of self-heal. So every topic what you're going to talk next is going to lead to another question. You need to be a little bit aware of that. It offers you features like what? It offers you naming and discovery. That's your kubedns running there, right? Core DNS out there. And it offers you self-healing, auto-scaling with the help of HPA. Provides you tools for deploying, rolling out and rolling back applications. It provides you features for monitoring with the help of probes. It provides you features for storing sensitive information with the help of secrets. You have to list out the 7-8, and many of them it allows you to compose your or build your own resources with the help of CRDs. Again, don't talk about topics which you're not comfortable, but these are few typical features which what we make use of. Self-healing, scaling, zero downtime rollouts. Maybe you should stop it there. Right? And deploying and managing and keeping your applications alive and running for you whenever you want it is what few features of Kubernetes. Of course, it provides you solution for volumes and distributed storage across all the nodes. It gives you feature of networking across your containers, across your pods, things around that. Moving on from there, because we need to go towards a little bit of harder questions too. What is Minikube? We know what's Minikube. Nobody uses Minikubes in production. It's a typical standalone cluster what we set up in development regions, all in one setup. That's what Minikube is all about. And if you want to read up a little bit, where do we go? We go to IO docs, right? Kubernetes.io/docs, and that's where you find things around that. It's all in one cluster, as in going to both work as master and worker node, where you make use of to learn, deploy, and learn your Kubernetes knowledge per se. Typically, we don't make use of this anything apart from that, right? So questions around this can be, okay, what other options do I have if I want to learn Kubernetes on my own and not spend money and things around that? Playgrounds can be one of your trump card, where we've seen play with K8s and many Magic Sandbox and things around that. Those can be offshoot questions from this question as well. Then, how is Kubernetes different from Docker Swarm? How are Kubernetes and Docker related? Can anybody help me with this? I don't know what the answers for these are. Let's tackle the first question first, and then that's two different questions out there. First one is, how is Kubernetes different from Docker Swarm? Let me answer that. Both of them are container orchestrations for you, right? Docker Swarm is a native orchestration tool from Docker, whereas Kubernetes is open source. Made open source, donated to CNCF. CNCF is managing it. Our next question is, why is Kubernetes the de facto orchestration tool? Why not Docker Swarm? Docker Swarm is a native tool from Docker, and it takes less than maybe 5 seconds to set things up. If I have a standalone Docker host running out there in a non-Swarm mode, what does it take? I don't need to install any other components, right? All I need to go do is Docker Swarm init on the node, and that becomes manager. As simple, takes what? 10 seconds, 15 seconds, not even 10 seconds, it takes you 2 seconds. And it gives you the join token. You go on worker node, which already has the Docker in nothing. All you do is Docker Swarm join. Cluster setup in 5 seconds, 10 seconds, right? That's the beauty. But why are not people using it? Now, the de facto orchestration tool is Kubernetes for containers, right? Look at any solution, everything runs Kubernetes under the hood. There are some enterprise solutions like Red Hat's OpenShift, Rancher Labs, or SUSE's Rancher, and other things around that. Everybody runs Kubernetes. One answer you can give is because it's a tool from Google. Typically, when you tell that, they will laugh at you. Like, come on. No, just because if it's a tool from Google, so what? What's the big deal? You can build on top of it. How Kubernetes came into existence, where Kubernetes has a track record of doing what, it is built on the principles which helped Google to deploy and run billions of containers. It's the proven track record what it brings to the table. It's open source, and the whole source code is available. You can look at it, you can add your own resources, and you can build around it. There are millions of contributions and contributors around the Kubernetes. Because of its being open source, because of so many people contributing, the contributors are your Google, your Meta, your Apple, your Cisco's, all the top people are out there. because it is open source, the innovation also it's happening at the Rocket space there. A lot of contributions happening, a lot of things around. Docker Swarm is the closed source. Docker, of course, maybe with a team of 100 engineers and you're competing with million engineers outside. That's, you don't tell all of these. I'm telling all of these for your understanding purpose. That's where Docker Swarm lost out. Long story short, both are container orchestrators. Both are doing what they need to do. They offer similar features, but Kubernetes offers you more features around it. Docker Swarm gives you, how you can join them as cluster. It gives you services, what we call it as like replicated and global, similar to your daemon set and replica set. And it does automatic load balancing for you, gives you ingress, creates an ingress network. It does all of similar things what it can do. It gives you self-healing as well. But it lost out to Kubernetes long ago. And that's where the Kubernetes is defective. Right? Few of the differences I told you around, the open source, closed source and stuff around that. The next questions around that is how are Kubernetes and Docker related? Well, they are cousins in a way. I'm just joking. Docker is your container runtime, right? Which needs to be running on every node of your cluster. Say, for example, if you have a 10 node cluster, which is being managed by Kubernetes. Kubernetes is the high level technology which will manage like what? Like taking your scheduling decisions and storing your configuration, helping those controllers keep an eye, monitor, deploying, making sure the applications are running, keeping an eye is the job of your orchestrator, that's your Kubernetes. On those nodes, like 10 node cluster I have, on those nodes, the job of Docker to act as container runtime, meaning go pull those images from the registries, what you're telling it to do, download those images on the node where you are, build that container, start that container, keep on running that container. So that's where Docker and Kubernetes are related. Docker is that low level technology which manages your container lifecycle, where Kubernetes is your high level technology which looks after the deploying, orchestrating and managing, scaling and things around that. Right? Then moving on from there, what is the difference between deploying application on hosts and containers? Who wants to take this?
I think when you're deploying on a host, that you are basically it's a static list of software that you have been installing. It's very dead. Whereas in container is basically packaged your infrastructure that supports your application is packaged along with your application. So it's easier for you to move from one particular system to another system deploying. So your package is, it's like your code.
Okay, good. So how do you package that code?
Your package is basically like with the Docker commands, like in the Docker commands available that you build infrastructure, like what kind of OS you want, what kind of like if you are building a Java application, what kind of Java version, if you're employing a Tomcat, you basically say that what Tomcat web server, if you have a web server, you include web server. If you're creating any config directory, you include that into your Docker file. You add them and then you do the Docker compose build.
Exactly, that was the difference I was waiting for. Typically is what, when you deploy your applications on your host or your VMs, your physical or virtual machines, you download the source code, you download the binaries, you build the environment around that. That job is yours, right? Like for example, typically if I deploy an application, if I have an empty server, I ensure I download the source code from maybe the GitHub, I install whatever versions of Java maybe I need, I'll compile them, build them, run them as object code, executable, run them. But deploying them inside the containers, what they would be looking at is trying to open up another conversation from you, is putting the applications in containers, meaning putting them in Docker files and Docker images. Image is what you need to run a container. That's the major difference. It's image is like a template what you have, which you make use of and spin out many containers from it. Usually it's an entry point question to talk to you about the images in Docker file. Major difference is that, right? Because on server, I just can download the code and compile and run it. Runs that way. Of course, I need to set up the environment and it works. But when I want to run them in containers, I just can't put it the way it wants. I need to write the Docker file for that. I need to build the image, and without the image, I can't run a container. That is the major difference, right? Otherwise,
so can we say that when you deploy your application directly on a host, you need a necessary dependency, right, which needs to be installed on a host. But that is not the case in container, where we need a Docker image that have all the necessary dependency you need for the application to be installed, like in terms of bins and library.
Correct. That is true. That is 100% true. That is what I was talking about. In the end, what they will turn this conversation towards is Docker file. And next question for what you answered was, oh, very nice. How do I do that? Now, how do I ensure that all the dependencies are part of that container? And how do those dependencies get there? And why don't they get there on the host? Is because when you do it on the host, I can give you the same instructions. It's up to you to execute them, right? So the main problem is I gave you a set of instructions. You did not follow it, maybe. I asked you for an install specific Java version, which you overlooked. And as a reason, my application is not working for you on a host. But in image, it works because image has all of them because we have built it. And how did you build it? Docker file. I mean, what you answered was correct. I'm hoping you're trying to get my drift. It's usually a question which steers you towards that. All right? Awesome. Okay, there's few basic questions, right, which you can expect. And let's look at the architecture-based questions. We spoke about this already. I realized this question is coming next. I just spoke about API server and I stopped myself and we moved away. We know what different components of Kubernetes architecture. At the very, very high level, we have what are different components of Kubernetes architecture. If you just look at it, we have control planes and the data planes. Skip the jargons, master and worker nodes. What components? API server, etcd, scheduler. We spoke about that. I stopped at API server. I did not go forward from there. etcd, we know what etcd does. It's our database. It's a stateful part which only persists. Has two things primarily: the entire state of my cluster and my entire current configuration. How does it get there is the next question. First, whenever you post anything to API server, how do you post? Whatever maybe kubectl, GUI, whatever you do. Run those kubectl commands. It's going to convert that and post it to your API server. It does what it does, and it stores that information, what you have posted, that manifest file, as your desired state, or as we call it as record of intent. It goes there where in your etcd. That's how it has entire configuration of what you want to deploy, right? And then the entire state of my cluster as well. It knows which node is running what content, what parts, what is the memory, CPU, disk pressure on those. It has all of that information. So etcd becomes very vital component for me, because if I don't have etcd, I don't know where to schedule what is running. If I have to self-heal when things break, I should know where things are running, how things are running, things around that. Right? That's what etcd has. Current state of your cluster, entire configuration. We know how the entire configuration got there, because we posted it got persisted there. Current state, we also know the kubelet and the API server constantly exchange the node lease, or putting it in a common term, the heartbeat. Anything changes around that kubelet informs your API server. It's a loop back which keeps on going on. When we do a describe of node, we see that information as well. And let me see if I can. No, I don't have my cluster up today for this. Sorry. So if you have a cluster up, just do a describe node. It talks about when did that kubelet post information around. That's what etcd has. Additional question around that can be around etcd backup, or can we run this component separately? We know all the answers for that. Right? Now, questions around architectures. I'm not going to spend too much time around it. What's the role of API server? What's the role of scheduler? API server, I spoke to you about it. Scheduler, I did not speak to you about. Let's talk about that. As the name suggests, scheduler is what? Is the one which is going to tell your API server where to go. Does a fair job. It tries to balance the load, across the workload, across your cluster in a nice fashion. It tries to equally distribute the load. Scheduler, in short, is the one who tells you where to go. You have 100 nodes in your cluster and you want to create some pods. Where do you go? It tells your API server where to which kubelet to talk to. That's your scheduler, right? How does it do? It watches your API server for any new work tasks, assigns them to appropriate healthy nodes. But behind the scene, what this guy does, it has a complex logic built into it. Like, it filters out the nodes which are not capable of running what you're trying to run.
Hi guys, I hope you're enjoying the video till now, and just to inform you that this is a clip taken from one of our sessions, and if you want to learn more about our sessions, then you can register for our free class on Docker and Kubernetes certification to get higher paid jobs. And if you want to register for the same, then you just have to visit K21Academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now, select an event date, enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of URL on the extreme right. You just have to add that URL to your calendars, save it, and we'll meet you in the free class. Watch the video till the end.
Say there are 100 nodes, it filters out, and we have come to 50. How it filters, we'll get there, all right? Out of 50, I just need one node to deploy my pod out there. So it's going to rank them, it's going to score them. Right? Once it's filtered out what are not capable, and it does ranking. It scores them based on few things. It has its own internal parameters like memory, disk, CPU pressure, taints, tolerations, and things around that. Your affinity, anti-affinity rules. There are 12 or 13 things it checks. We don't need to get there, but if they ask you on top of your mind, you can say, your requests, what you put. We will get there. Okay, be with me. Sorry, I'm going a little off topic. Scheduler does that and it ranks them. A node with the highest rank is selected, tells the API server this is where we need to do, and the work gets done there. That's the job of your scheduler. Tries to equally distribute the load, takes care of it. We usually don't need to tweak that guy. But when we want certain things to happen the way we want, we can tell our scheduler the filtering criteria. Like what? When I create my manifest file, I can tell my scheduler under my container manifest telling the resources. Remember we spoke about that? Request and limit. Request is the information what scheduler is going to make use of. By default, your container can consume how many hour memory and CPU available on the node. We don't run that way. Why? Because if the badly written code, there's a memory leak, that whole pod is going to consume all the memory on that server. We've spoken about these concepts. I'm hoping you're able to recollect it. And as a reason, what do we do? One of the reasons, many others as well. What do we do? Is we make use of resources on our pod spec, and we say requests and limits, right? So whatever you mention under request, you're requesting your scheduler, put me onto any node, I don't care, as long as that node has this whatever requested amount of free memory or CPU I'm asking for. That's how you tell your scheduler. We also saw how request is one of them. What scheduler is going to make use of. It's going to listen to you. Your desired state is what it wants. Then what else can alter the scheduler behavior? Our labels can alter them. Node selectors is what I'm talking about. Node name is also what I'm talking about, where scheduler does not get involved at all. You give the name, it goes there. With the help of scheduler, we do node selectors. We apply labels on those nodes, and we tell our scheduler, can you go to this particular node which has these labels? We have seen that as well. What else can affect your scheduling behavior? Taints and tolerations as well, right? So, the question was, what is a role? I should have stopped talking there, but I wanted to speak to a little bit about the scheduler as well. So we kind of covered the 4 components: API, HCD, scheduler, controller, different questions. All right, good. Can you brief about controller manager? What do you understand by load balancer in the Kubernetes world? Question can be tricky. When we say load balancer, there are 2 things they can be pointing towards. One, load balancer needed for setting up a high available cluster of masters. Control manager, we've spoken about it. I'm not going to repeat that. And when they say not properly worded question, maybe here is what I feel. Load balancer in Kubernetes, I think they should be referring to either load balancing of your multiple masters you have, or load balancer type of service is what they're talking about. Right? Now tell me, what's a load balancer type of service? What's the difference? Or What is it all about? I don't know. The four type of services. One is called it as load balancer. Cluster IP node port load balancer. What does the load balancer type of service do?
Load balance is like going to expose our application in our cluster.
Okay. I have a cluster setup. Good question. I mean, it's a good answer. Now I have a cluster setup myself with kubeadm, right? A self-managed Kubernetes cluster, and I'm going to create a type of service called as load balancer. Okay.
Are you talking about Ingress?
I'm not going there. I'm getting there. We're talking about a third type of a service called as load balancer. Now, before I go there, what are the type of services what you can create in the Kubernetes cluster? There are four, right?
We have a four type of services like node port, load balancer, cluster IP. These are the services in our Kubernetes cluster. Kubernetes.
Correct. True. External name is the fourth one, where you want to connect to some external sources like DB is running on different server from your application. You make use of that external service. Good. Okay. Then external name is that one. Now the question is the third one, the load balancer. What does it do? Load balancer type of service. Now the trick question is, here is the question, right? I have set up a cluster of myself, self-managed cluster. I've picked up some VMs coming from my data center, and I'm going to create a service as load balancer. Then, okay, so it's expected to create a load balancer for me, give me that IP. Now the question is, where is it going to get that load balancer? How is it going to configure the load balancer? Which load balancer is going to make use of? And you can't provision the load balancer automatically. The load balancer type of service is what we're talking about. Okay. So if you're running a hosted solutions like AKS, EKS, GKE and things around that, there is that fifth component in our cluster control plane called as Cloud Controller Manager. My bad. Cloud Controller Manager. Job of that guy is to integrate your Kubernetes with your underlying cloud API. That's in a hosted solutions. That's the typical example what you have. So if I'm running AKS, for example, and I say go create the load balance type of service, cluster IP, node port sits on top of load balancer sits on top of node port has cluster IP, right? So you have cluster IP, you get node port, then you get another IP address, that external IP what it shows when you do get service, that's a load balancer IP, which you don't need to provision, which you don't need to configure. Your Cloud Controller Manager is going to talk to your underlying cloud API, get that load balancer, internet facing load balancer for you, give you that IP address there. Self-managed clusters, it does not. So like how Pankaj said, if you really want, you configure yourself. MetalLB, HA proxy, traffic, whatever. Take that, edit that service, add that as external IP there, then it works. Okay, that can be trick questions. Only it works in the hosted. What do? They give you internet facing load balancer. Good. It's going to charge you. That's where the question of ingress comes in the next. That's where the question of ingress controller comes in next. Because if you have 100 applications deployed and you expose 100 applications to the outside world with the help of load balancer type of service, works beautifully fine. But what you have to do is you end up paying for every load balancer once you make use of. That's where ingress controller comes into picture. You create the ingress rules, the path-based routing, where you say, which server application to route to. Instead of using 100 load balancers, you make one load balancer. And when you hit that load balancer based on the rules what you have created, the ingress resource, the ingress controller will take it off routing it. That's where ingress comes into picture. That's where you need to go look at it. Moving on from there. What is the difference between a replica set and replication controller? Replication controller got deployed long back ago. I don't know why this question in the slide though. Now deployment controller makes use of replica set behind the scene for self-healing. Major difference is replication controller. It's been a while. I haven't looked at replication controller, maybe 3-4 years. It's equity based and set based selectors is what it makes use of. Remember, when you write a replica set under selectors, you do match labels and then it gives you some more options. of not matching, equal to and not equal to, greater than, less than. Some selection criteria is what you get. But in replication controller, what you use to have is equity, 1:1. Like in node selector, you say match labels, and node affinity you make use of, it gives you some more options. That's the difference between replica set and replication controller. But apart from that, I don't remember top of my head. We might have to look into the documentations for that. I'm going to skip that question because it's been a while from the time deployment is out there. It matured in 1.15 beta. I don't remember. Growing old. Good. Okay, what are the best security measures that you can take while using Kubernetes? Again, it's a trap question for you. Why? Security is not at a small topic, right? Security can be at your host level, at your cloud level, at your code level as well, at your container level. Many things get involved. So whatever you know about security, you need to talk here. And whatever topics you are comfortable with. Let's begin with elementary stuff of how do we access our cluster. Right, that's the beginning of it. Well, we access the config file, and how do you authenticate is the question I'm talking. When I say accessing, authentication is what I'm referring to. Many ways of authenticating. I can put that in basic files like user ID and password. Kubeconfig set credentials. Remember, we have seen that where you can say -- user ID, -- password, -- token. I can set those static. In the API server, I can tell them go look at this information. Or we made use of PKI. We generated our keys, created a certificate signing request. My administrator signed that certificate signing request for me. I got that certificate. That's how I authenticate. So maybe you have to start small. This is a trap question. Like we have many options to look at. Basically, the authentication is what the questions is going to be around. So once we have authenticated, that's one story. And continuing on, which allows you to deploy and talk to your cluster. And what are the other security measures we make use of? We control who can do what with the help of role-based access control, right? That's where the concepts of roles, cluster roles comes into play. Then, which will lead you to different questions of what's the difference between role and cluster role. You will explain that role is scoped to a namespace, cluster role scoped across the cluster. Then they will talk to you about what is a namespace. Make note, these are a few concepts, basic concepts we need to know around it. So authentication is taken out, authorization is around rollback. Then we talk about security measures around the admission control as well, where I ensure that I set some policies across my cluster. Like I don't want anybody to be pulling images from their own repositories. How can I do that? Will be the next question. I will set up some image webhook which prevents or allows you. That is the admission control part of it. Don't get into topics which you don't know, but we can set some policies around, while maybe a policy not to create a privileged pod, where the isolation between the root user on the host and root user on your container is taken away. Those are the few measures around the initial API server what I think of. But when I run and write my application manifest file, what can I do is many things. All right, so another security topics can be what? Just thinking, security context. One was the authentication authorization, which we know, right? Again, it opens up to different questions. You should be comfortable with that as well. And then when you deploy your application, you need to deploy it in a better way. When I have access to build my own image, and if I adhere to the best practices, security best practices, what do? I build the image in a better way. Like, for example, to give few examples, I will ensure I don't bind to the root ID. I build my image, I make use of user as a directive. I'll build don't tell all this to the interviewer. I'm just telling you these concepts so that you can, remember and try to link them around it, right? So one of the best practice while building the image maybe is to make use of user. Not run as root is the point I'm trying to make use of. Use the instruction as user and switch to some other application. That's what you will do when you're usually building your own image. Then thumb rule is reducing the attack surface, right? So what do? Remove all the unwanted binaries from your image. How do we typically do it? Make use of multi-state Docker build, leave behind things what we don't want. We carry forward things what we want, right? Usually make use of removing or making the important config files as read-only. Again, we do this from the Docker file. We make our containers usually immutable by taking away shells. We don't want anybody to exec into our container. While building the image itself, if I take care of all of these, what happens when somebody creates a container out of that, it is already secure. But I have no control over. For example, Nginx image is what I'm using, which is built by somebody, Docker, and it's made available for me. When I am deploying that in my cluster, what kind of security measures do I take? They're talking about security context. I'm giving you all of these different facets. Make a note, whatever you're comfortable with. Talk around the things which you are comfortable around. Security context. What do we do in that? Where we define what your pod can do, cannot do. For example, can't do privilege escalation. Right? Can't run as a privileged container, true or false, Boolean value. Right? We know the concepts of Linux capabilities. Default, the container gets around 13 capabilities, 13 or 14. If your application does not need it, you don't need to have that. What do? Under security context, what do? Drop or add those capabilities or drop them. Right? So least privilege is the principle there. If your application does not need it, why do you give it? Drop them. That's what you do. Capabilities. Then can be questions around that too. Run as non-root user. You set that flag to true. Then what do? You need to tell it to run as a specific user. Run as a user, run as a group. Remember those security contexts? From a developer point of view, writing the manifest file, those are few things what we are going to make use of. Like I said, security itself is a wider topic where you can prevent unauthorized access to an API server, anonymous access to running an insecure port and not running an insecure port, running a secure port. And then you can come at security measures of auditing what is going on, encrypting your HCD, which is not encrypted by default. So it kind of opens up quite a lot of things, but stick to a few security contexts. And network policy is also a security measure where we do not want any unauthorized access from the outside world, where we restrict that with the help of network policies and ingress and egress policies we create. We've spoken about that. These are a few topics what I think of top of my head. Let me just give me a quick 1 minute. I'm trying to connect to my cluster. It's not allowing me for some reason. Well, I went to Google and I picked up the most commonly used example of deploying a microservices application. That's the microservices demo. Not sure if I showed you guys. Let me take you there. So if you go to Google, and if you want to look at, this is the Google's GitHub, right? Where Google samples, if you search of them, they have two applications. They're beautiful. One is your microservices demo, which works. There's another banking app also what they have. Nice stuff, right? I mean, I'm talking security. I'm going somewhere else. I know. I'm just showing you something. Maybe if I'm not showing you during the class. Typically, what this talks about is, this is how a monolith application is broken down into multiple services, and where each service is built in different language. You usually make use of this example when you're teaching microservices as a concept. Everything is built as different services, individual services, bundled as their own images, built and deployed, managed and run in Kubernetes cluster. Okay. I took the same example. I cloned the repository. It gives you the source code as well. You can do all of that. That's what I have done. Is the point I'm trying to come. It's an application boutique. You click there. Different services work different way. Okay. Good. Just doing little promotion for Google. They do a pretty good job. It's a very nice example. It helps as a trainer to look at that example and talk about it. That's what I did. And if I look at the manifest files, what they have, and there are many manifest files what they've built. One of them maybe is front end, which is what is going to create a front end deployment. If we just open that for us, here is what typical example what I wanted to show you. From a security point of view, maybe under specs you write few things. Like what? Like we have security context. Right? I told you run as a specific group, run as a specific user, don't run as root, you're setting it to true. Right? You're at the container level, you want to drop all the capabilities what your container can get by default, because my application don't need it. It does not need it, I don't want it to give it. And drop all is what they're doing, capabilities. Privileged container, the isolation, they're setting it to false. Read-only root file system, they're setting it to true. What happens? The whole container file system is running as read-only. Right? So attacker gets access to the container, he wants to modify something, nothing gets modified. he can't gain additional privileges than what the process is started. The child process by default can gain more extra privileges than the parent which is starting. But if you deny the allow privilege escalation, set it to false, it can't. So attacker gets access, you want to elevate his privileges, go do something, it does not allow him. All the capabilities are dropped, even though maybe he's running as root user, which he's not per se from here, but he can't do anything because there are no superpowers assigned to him. Again, the concept of Linux capabilities. So this is how typically you secure your deployment. One of the example is this nice manifest file that tried to cover a few things around it. So long story short, if that is the security question, from the developer point of view, you will talk about how you will secure it, like the way we are seeing it here. From an admin point of view, things become very complicated, as in if you make it. Because when I say I'm an admin, I need to worry about the security of the host where it is running. I need to worry the security of the cluster, the kind of containers I'm running. This is what I'm talking about. Then we can worry about the security at the code level as well. If you have credentials, tokens, passwords set in your code that's not right, then you lead them towards secrets and config maps and talk around that. Okay. Point to take away from this slide, what we were looking at, go look at security context. There are two security at the two levels. We have spoken about it. Just because we are seeing this, let's recap. If I define the context at the pod spec level, like the way we have right now, it's applicable to all the pods you have on the pod. But if you have the security context set under your containers, that's applicable only to that particular container. If I set under pod, the same security context I set under container as well. Whatever you have set under container is going to take precedence. We have spoken about it. We have seen it practically too. Just recapping that. All right. Now, this is the example I showed you just to showing purpose. I'm not sure we have made use of this or not. So this is usually what we make use of to show the microservices demonstration. Deploying an application on your Kubernetes cluster, if that is the question, this is the answer. Let me do that when I'm here. Let me quickly see what we have. Kubectl get all. Okay, Kubectl delete. Okay, good. I was just checking because this cluster was in a suspended state. I typically have to come back and reboot it. I'm just checking if I have to do it. No, it's going through. Let me apply this manifest file. It's going to create a few things. Go back and look at kubectl. This created multiple deployments. Each one of them got deployed as a service. We know all of that. This is what we were talking about. This is where I wanted to show you. When I say load balancer as a type of service, if that's the question on the service, you see the external IP gets pending. But same thing if I deployed on my AKS cluster right now, EKS, GKE, anywhere, I would have got an IP. Load balancer automatically configured. Load balancer is built on top of node port, so you get the node port as well. You can make use of a load balancer IP, or you can make use of a node IP and this port number, or internally you can also make use of your cluster IP and that port number of your choice. Load balancer. We had a discussion around that some time back. That's why I'm coming to this. All right. And this is okay. I'm going to move away from here. It's going to take time. Leave it. All right. So, like I said, again, you need to be a little cautious of what words you choose. Audit, container resource monitoring. I'm going to rephrase this question. It should not be what is. How do you monitor container resources is what would have been the real technical question out there. What is resource monitoring? You're monitoring the resources what a container consumes. Typical resources we have is what memory and CPU. But how do you monitor that? Or what features, what options do Kubernetes give you when you're doing a self-managed Kubernetes cluster to monitor the resources? Typically, your application needs that information. Like if a UI needs to talk to DB, for example, needs to know the DB connection string. If I want to do a secure communication, I have a certificate with me. I have my keys. I need to put it in the application path where the application needs to read it. Sensitive information which I can't put inside my image, can't put on. When I say I can't put, I can. But if I put it, anybody who has access to the image can read it. If I put it, anybody with access to the code can read it if I write it in the code. So we want to decouple that sensitive information. I want to store it somewhere. So when I create a secret, it stores it in your etcd, does not show you what those values are, and makes it available to the kubelet during the runtime. And an application container gets that and it makes use of it. Main difference is confidential, that is sensitive information, non-sensitive. When I create config maps, I have some application configuration data. Based on different environments, the application config might change. I don't want to hard code that with an image. Say 8 KB is a DB block size in dev, 64 KB in production. So I don't need to hard code this configuration, build it as two different images, tag it as one image built for dev, one image built for prod. Nope. Instead, what will I do? I will make use of this configuration information, which is non-sensitive, which can be viewed by anybody if I want. Create them as config maps and inject it to your pod during your runtime. Just like the way secrets get used, config map also get used. Next question, which is going to lead you from here, is how do I make use of them? Either as the environmental variables env or as files in a volume. Both of them same way. You can create them with one of the example you can use for secret is the Docker login, maybe the Docker config, what it creates, right? Sensitive information, your ID and password. You don't know pod will go to which node, so you don't need to remember which node. If it is a private image, you need to authenticate, correct? How do you do that? You have to log into that node and say Docker login. 100 nodes, you can't do it. You take that ID and password and create it as a Docker config secret. It is stored, passed on during the runtime, made available by kubelet, fetches that image for you. One of the example that's called as an image pull secrets. We have seen that as well. Major difference between config map and secret is sensitive and non-sensitive. One is stored in base 64 encoded, another is in the plain text. Then maybe if you talk that, they will ask you about encryption. Don't get there. By default, they are not encrypted though. Anyway, that's the major difference, right? Try to give some examples like the way I did with the Docker example and stuff. That makes it easier. Then let me answer that. Okay, toleration is the right answer. We will stop it there and we'll move on. But if you want to score some brownie points, you can say, not only toleration, that's the right answer though, but we can do some more things. We can create them as static parts where kubelets on the node manage directly. Scheduler has no role to play there at all. Drop the manifest file where the kubelet looks for. Typically by default is /etc/kubernetes/manifest. Drop it there. And then kubelet is going to manage that. That's the second way. Third, I can tell my API server what's my desired state. And it listens to your desired state, correct? So when I post my manifest file, in that I'll mention a node name as my desired state. I'll say go to master for my example right now. That's my node, that's my desired state. So when I mention what my desired state with a keyword called as node name there, I am telling the API server where to go. It's not even going to ask the scheduler where I need to go. It asks the scheduler, that's when scheduler does your filtering, scoring, that's where your taints come into picture. But when you tell what is your desired state, you are the boss. It's going to go there. The scheduler is not going to get involved when you specify the node name. First and top priority answer, tolerations is what they're talking about. What are toleration? What are taints are the offshoot questions of it. What are different effects? No execute, no schedule, prefer no schedule. You should know around it. Good. Then on top of it, you have node name. On top of it, you have static parts. All right. Can we use many claims out of a persistent volume? Explain. Maybe not rightly worded question though. We have a persistent volume. Can many claims bind to it? Is what I think they're trying to ask here. Only one-to-one mapping. You write a claim and you have available volume out there. It's get bound to that claim. That claim can be used in different parts you have, right? Which is again going to map to the same volume. That's why it is. So if you have many claims, once you have created that claim, if there's available volume matching your access mode or matching the minimum capacity what you asked for, what is it going to do? It's going to bound that. Once they both are bound, then they're bound. Until unless do what? Until unless you don't delete the claim, and when you delete the claim, until unless whatever your reclaim policy has been set to, there is retain, there is delete, there is recycle. Recycle, I think, is taken out right now. So this question again opens up a lot of other questions around access mode, maybe around capacity, around storage classes, maybe mainly a volume question. Long story short, the typical answer for this is one-to-one mapping is what is done. Until unless you don't release the claim, delete the claim, and whatever your retain policy is, maybe it is delete, it's going to delete that volume and put that, or if it is retain or recycle, it's going to recycle it and put it back, make it available again. Okay? Then, what kind of object do you create when your dashboard, like application, queries the API to get some data? Pod is what everybody creates, right? Now you have different type of controllers. What kind of controllers? For example, replica set, deployment, daemon set, stateful set. Job also is another controller. Every controller has different role to play. Like deployment gives you self-healing, scaling, Stateful set does something else. What does job do? Job also creates the pod for you. Pod is the most basic atomic unit. That's where your application gets deployed. That's where your application runs. You have different kind of workloads which don't need to run continuously. Meaning, the way Kubernetes is designed, when you deploy an application, it ensures your application is up and running all the time. The restart policy is set to always. The application runs to completion, gets killed, errored out, whatever the story, it automatically restarts that and keeps it available. That's the design principle or concept what they make use of to make your application always available. But now I have some type of workloads. Like what type? Some batch processing, some analytics, some report jobs, some workloads which needs to run, do some computation, get out of there. I don't want them to be continuously running. Like I want to generate a report, send out an email, I'm done. I don't want that application part to keep on continuously running. For workloads like that, you don't create them under a deployment controller. You make use of a controller like job, which will ensure a pod gets created and it runs to completion. If the job or the pod fails in between, you can say, instead of making use of a job controller, I will make use of restart policy set to never in the pod, and I will run. Correct? Because if the default restart policy is always set to always in the pod, and that's why it runs to completion, it's getting automatically restarted. Kubernetes is doing that for you. You might argue with me, I will create a pod still and I will set the restart policy to never. So the job is going to run, the application, the pod, whatever we create is going to run. It's going to run to completion. Then what is the difference between job and pod? Correct? When you create a pod that way, it works fine, absolutely fine. If that fails in between, there is nobody to control. Keep an eye on that. So workloads like that, you create them under a controller called as job, which spins out the pod for you, ensure it runs to completion. In between, when it is running that pod, that whole node fails. The job is incomplete. That pod did not do the batch processing. You need to spin up one more pod which is going to run to completion, things around that. So job controller keeps an eye on that and it helps you do all of that. That's a job as another controller. Then we have jobs which need to run on specific intervals. I need to run some typical workload every 1 hour, 2 hour, every once a day. That's where cron job controller comes into picture. So you have pod, you've created job on top of it. Now you want to run that at a specific schedule. You make sure cron job is the controller what you're going to create. All right, good. So that's the difference between your job and a pod. Job is the controller which manages your pod, which ensures the workloads run to completion. How do you deploy a feature? I think when they say a feature, they're talking about a deployment, a feature of your application is what they're talking about, with zero downtime in Kubernetes. There are many controllers which provide you that, like daemon sets and deployment. Typically, we make use of deployment. Daemon set also provides you the rollout feature though, where you can roll out. Stateful sets also do that, but in a graceful ordered fashion. Deployment is what you make use of. And in deployment, there are two types of deployment strategies. One is rolling update, one is recreate. When you make use of rolling update, it updates it rollingly, as in it scales up the new replica set, creates new parts, and then once they're ready, it's going to terminate the older ones. That's your rolling update feature. Then the offshoot question from that is, what does recreate do? Recreate kills and brings it back. That's not zero downtime though, but it updates it, right? Deployment is the answer for that. Moving on. How to monitor that pod is always running. You don't need to monitor that. There's a restart policy is the question for answer for this, which by default in the Kubernetes world is set to always. Restart policies. You remember we spoke about them. There's always, never, on failure. In Docker world, no is the default value. Here always. So Kubernetes is going to ensure you don't need to add that specifically. Answer for that question is restart policy. Alright. I'm going to skip through basic questions. Is the way to make a pod to automatically come up when the host restarts? Is there a way to make a pod to automatically come up? I don't know what that means when the host comes up. There are two ways to look at it. If you're running it as a static pod, if the kubelet, when the host restarts, the kubelet needs to be running as a system service, and the kubelet restarts, the pod also is going to come up. That's a static pod way. I think what they're trying to ask you is, if a node fails and there's a pod running on it, what happens? That's a self-healing. If you have created it as a singleton pod, that pod is gone forever. Nothing happens there. If you've created it with some owner on top of it, some controller on top of it, like deployment, replica state, stateful set, then that pod is going to automatically get created somewhere else. All right. Sorry, I'm running out of little time. I'm going to skip through some scenario-based questions. A company has built a monolith architecture, handles numerous products. Now the company is expanding in scaling industry. The scaling architecture, monolith architecture had causing problems. How do you think the company shifted from monolith to microservice and deploy this service containers? Well, it's more of a microservices question. I'll tell you a typical answer would be, that's the challenge. What they've written is the challenge with the monolith architecture, right? And you want to scale up, you can't really. When you scale up, you need to scale up the whole application. You can't scale up just the typical components what you want to make use of. How would they do? It's the architecture style. How would they have done? There's a pattern called a strangler pattern, where you break down your monolith application to smaller. Let me show and tell. Hold on. That is what it can be, and it's more of, what can I say? How do you think company shifted? I don't know what they made use of, but typically what we do is what I'll show you. This diagram is what I was looking at. So if this was the problem they had scaling, they had to go to microservices and break it down. The problem is there's no straightforward yes or no kind of an answer for that. Every application is different, and with that it brings different capabilities or complexities to the table. How you break your application depends on your business capabilities. Their domain-driven reason, their business capabilities you break these services are. Typical way to do it is, start by adding your new services as services. Existing one, you break them slowly and take out one chunk after that. In the end, what you have is across the time, your monolith application strings, and you have deployed all of them as multiple microservices. Again, these are scenario based, and how well you understand these concepts you need to talk to them about. But what I thought about of this, I thought I should bring this up to you. Okay. Then going on, consider a multinational company with very much distributed system, with large number of data centers, virtual machines, many employees in tasks. How do you think that such company manage all the tasks in a consistent way with Kubernetes? Again, scenario based. They have to make use of some pipelines, some CI/CDs. They need to ensure they set up automation. That's where they're looking at. And automation, CI/CD pipeline is the answer for that. And again, the question is, what is CI/CD? How do you integrate? What are typical tools we have? We have Flux, Argo CD, Jenkins, many of them, right? Again, we're going to skip through these. Company wants to increase efficiency and speed of its technical operations by maintaining minimal cost. How do you think the company will try to achieve this? Many ways to looking at it. Reserving the instances is one of them, which saves your cost for you in the long run. Things around that, right?
So guys, this was a clip taken from our step-by-step comprehensive program that has 16 modules, 60 plus lessons, 35 plus hands-on labs, CV and exam preparation, and the most important, on-job support. So this comprehensive program is specially curated for you so that you can be from beginners to a master and you can master every skill set that has been required here. And if you're somebody who would want to start off their career in the domain, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paid jobs. And don't you worry, this interactive session will help you in gaining the understanding of why learn containers and Kubernetes, what is Docker container architecture. We'll be discussing about pod with highly available and scalable applications on Kubernetes. We'll be having demo so that you can perform really, really well. And now if I'm talking about that, what special do we offer? We have the comprehensive learning path for Docker and certified Kubernetes administrator course. So in week 1, we'll be talking about microservices and Docker. Week 2 is about Docker, networking, storage, and app stack. Week 3rd is about Kubernetes architecture and installation. In week 4th, we discuss about security, troubleshooting, and high availability. Week 5th is about networking, that includes all the networking policies, securities, contexts, and whatnot. And one thing that I have to mention here is that with every session, we have labs so that you can practice whatever is being discussed in the class, and this give you a knack over everybody because you will have the practical knowledge. Coming to week 6th, we are talking about deploying of daemon processes and whatnot. Week 7th is about application stack. Week 8th, we talk about advanced networking, of course, followed by some different laboratory sessions. And in week 9th and 10th, we are completely focusing on your certification preparation. That includes project work. Then we have certification practice part 1 and certification practice part 2 as well. And in week 11th and 12th, this week is completely dedicated for your CV preparation and your project work, because project work is something that is going to help you with all your exams and of course interviews as well. And now talking about the hands-on labs, and as you can see on the screen, we have almost every topic covered. So with every topic, you'll have a fine-grained understanding of whatever topics we are covering, and each topic you can have a practical knowledge that is going to help you in your examination and of course in your jobs. We also have sample exam papers in PDF format. And here you can definitely see on the screen that what kind of questions we have, and these questions are going to make you prepared for your exam and your interviews. So if you really want to have a basic and if you really want to see what all we are going to cover, then we have this free class where we'll be talking about why learn Docker and Kubernetes and Docker containers architecture, image and containers and whatnot. So if you want to register for this free class, then just have to log on to K21Academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now, select an event date, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface where you just have to save this link on the extreme right, add it to your calendars, and I will see you in the free class. Till then, keep learning.